Okay, lesson 10A, we're going to look at an introduction to scatterplots. So these are things that you have seen before, probably Algebra 1 and Algebra 2. All right. It is a way to display the relationship between two variables. We're going to talk about describing the direction, form, and strength of association. I'll go into detail on those in a second. All right, and then we have the response variable and the explanatory variable. This is just like we talked about when we did experiments. Okay, remember response variable, the more common word that you have probably called it is the dependent variable. That's measuring the outcome or the result. And then the explanatory would be the independent. That is the thing that is causing the change in the response variable. Okay, so DFS, direction, form, and strength, that's something you need to be able to look at a scatter plot and describe. So when we're talking about direction, it's generally either positive or negative. So as we go left to right, the dots are mostly going up, mostly going down, or there could be no correlation. There's no real form here to these, so we would say this has no correlation. We talk about the form of the association. For our purposes in this class, we're just talking about, is it linear or nonlinear? Okay, so does it kind of form a line? Can I draw a line kind of through all the points? Or does it form some other shape of graph that you have seen before? So like this is sort of a parabola shape. Okay, so linear or nonlinear is all we're going to talk about in this class. And then the strength of the correlation has to do with how tightly packed the dots are in our scatter plot, how close together, like if I could draw one straight line, would it go through a lot of them, or would they be more spread out? Okay, so strong, weak, moderate, those are kind of the words that we would use to describe the strength. We have a way to actually measure the strength of association, and that's called the correlation coefficient, right? It's represented by the letter R. It is always somewhere between -1 and +1. Okay, -1 if the graph has a negative relationship, and then +1 if it has a positive relationship. The closer you are to one of those numbers, 1 or -1, the stronger the relationship. So, 0.8, 0.9, those would be strong. -0.8, -0.9, those would be strong. Okay, and so what we're going to do is go over how to make a scatter plot and get the equation for the line of best fit as well as that correlation coefficient in Desmos. Okay, so I pulled up my Desmos window here, and what we need to do first is put a table into Desmos. So at the top of where you would type things in, there's a plus sign, and we're going to add a table to Desmos. And I'm just going to type in these numbers. So 1, 10, 5, 15, 3, 24, and 30. Okay, and then over here, the y value is 12.5, 8.7, 14.6, 5.2, 9.9, 3.1, and 2.7. And you can see over here, and I'm going to make it bigger here in a second, Desmos now has created my scatter plot for me. So they have plotted those points. So like 12.5, they have gone over 1 and up 12.5 and plotted that point. So they've plotted all the points so I can kind of see the trend. So if we were to describe this using our three terms that we talked about, direction, form, and strength. All right, direction, I would say this is negative. As we go left to right, the points are generally going down. The form would be linear. I could almost draw a straight line through these points. And the strength, I'm going to call this moderate. All right, I could kind of draw a line through them all, but it wouldn't be exactly perfect. Okay, and then what we're going to do is we're going to get the line of best fit, the actual equation of the line that matches those dots, and also the correlation coefficient. Desmos will give us that as well. So back where I typed in things, I'm going to go to the next line, and I'm going to type in that equation that I gave you earlier. So it's y1. Now, if you just type y1, Desmos will automatically pop it down as like a subscript, so you don't have to worry about how to do that. And then it's not an equal sign, it's a tilde. And a tilde is the little squiggly mark. It's right next to the number 1 on your keyboard, but you have to press shift. Sorry if you hear my dog whining in the background. And then we're writing slope-intercept form. So m and then x1, and again, Desmos will automatically pop that 1 down, and then plus b. And so you see over here the line has formed that kind of goes through all the dots. That's the line that best describes the relationship between those dots. All right, and Desmos gives us, so they give us our equation in slope-intercept form. They give us m, which is the slope, and b, which is the y-intercept. The problems will tell you what decimal place to round to, so we'll do this one to 2 decimal places. So my equation would be y equals negative 0.38x plus 12.88 if I rounded those things. All right, so that would be the equation that describes this relationship. And then the R value is negative 0.9078. Negative 0.9 is very close to negative 1. All right, so that is actually a very strong relationship between the years out of school and the annual contribution people make to their school. So the further you get out of school, that annual contribution drops, and that is the equation that and scatter plot that shows us that relationship.